Hello friends, today I'll discuss about function of wave trap or line trap in a substations. So a diagram has been shown by showing the position of the wave trap or line trap connected in the transmission line. Wave trap is connected with the series with the transmission line and before entering into any bay equipment of that transmission line. And in parallel with the wave trap, we have a coupling capacitor. So this wave trap play a vital role for power line carrier communications. So what is power line carrier communications? Transmission line is normally used for power transmission, but in the same line we can use for carrier communication such as teleprotection, voice and data communications. This carrier communication is normally done in the frequency range from 30 to 500 kilohertz. And in case of power transmission, the power frequency is 50 Hz in case of India, and in case of other countries, it is 60 Hz. So basically, since WebTap is connected in series with the transmission line into a bay, and after that all the bay equipment are connected, bay equipment like line isolators, line side CT, circuit breaker and the lines bus side isolator, all these equipment are connected. So this wave trap prevent the high frequency signal entering into the substations. So wave trap is a vital part for power line carrier communications, and power line carrier system or signal is used for remote control signal. That is, from the remote end we can control the operation of the circuit breaker, operation of the isolator. Number two is voice communications. Voice communication between two substations can be established via power line carrier communications. Number three is remote metering. Metering of that substation can be fetched via this power line carrier communication to remote end substation or any other end. And number four, which is a vital part, is pilot protections. That is, the carrier added protection tip can be done via this power line carrier communication. Power line carrier communication are done in very high frequency in the range of 30 to 500 kHz. Since wave trap is connected in series with the transmission line and the value of the inductance of this wave trap is very low, that is of the order of 0.5 milliohm, and that is why this wave trap provide low impedance path for power frequency signal, since power frequency is 50 Hz in India, and for high frequency signal wave trap block this type of power line carrier communication to enter into the substation, and it divert to the coupling capacitor circuit. Now inductance of the wave trap is very low, that is of the order of 0.5 millihenry in case of 132 kV, 220 kV and also for 400 kV system. So at power frequency, since power frequency is 50 Hz in India, the impedance offered by the wave trap, that is Z, is equal to omega into L. Omega is equal to 2 into pi f, and since f is equal to frequency of the system is 50 Hz and L is the 0.5 millihenry. So we can get the value of the impedance offered by the wave trap at power frequency is 0.157 ohm. So it offered low impedance path for power frequency signal. Now, in case of the high frequency signal, for example, consider the high frequency is 400 kilohertz. So, impedance offered by this wave trap at 400 kilohertz will get as omega into L. The value of the L remains same, that is 0.5 millihenry, and here the frequency is 400 kilohertz. So, we will get the value of the impedance offered by the wave trap is equal to 1256 ohm. So the wave trap block this type of high frequency signal, and it is diverted to the coupling capacitor, which is connected in parallel with the wave trap. And coupling capacitor is provide a low impedance path for high frequency signal. Since web trap is connected in series with the transmission line, it must be designed to carry rated current and also the thermal capacity of the conductor which is used for the transmission line. If it is a Panther conductor, then the web trap is designed to carry the rated thermal current of that Panther conductor. So current carrying capacity of the web trap depend on the conductor of the transmission line. Again, since it is connected with the series with the transmission line, it must withstand the short circuit capacity for short duration of time. The different component of the web trap has been shown in this figure. From the different component of the web trap, we have main coil. Main coil is air core dry type power inductor made of aluminum standard wire. The inductance of the web trap of voltage rating of 132 kV, 220 kV and 400 kV remains as low as possible of the order of 0.5 millihenry. Then we have the tuning devices. Tuning devices is provided in parallel with the web trap in order to adjust the blocking frequency range. Then we have the lightning arrestor which is connected in parallel with the tuning devices and the web trap in order to protect these devices from surge. Then we have the bird barrier and terminal. Terminal is connected to the transmission line conductor and to the bay equipment. So friends, if you like my video, then do subscribe my channel and press bell button for notification of videos to be uploaded in future. Thank you for watching my video.